Um, just a quick note before I get started. You know, in many ways, this project began for me. It was sort of born out of my sort of, how you say it, less than careful research in the summer, and I would usually come home and discover that some bit of archival data had been missed, and oh crap, now I got to wait 3 months or 6 months or whatever to get back to the data. And so for me, this was really just I can't speak for Tim, but for me, this was just a project to make things digital so I could have them on my computer, and then it seems to have grown into something else, and I really feel like I'm sort of falling down a rabbit hole. So, you know, it's nice to know, I mean, this session is wonderful because it's nice to know that there's people like Bill and Brad and Adam that are at the bottom of the hole, either to fall on or to catch me whenever I land. So there we go. It's been quite a while now since classical archaeologists went digital, and to judge from our widespread use of electronic tools and media, it's safe to say that we're commonly agreed that this is a good thing. Today we can gather, analyze, and share immense quantities of archaeological data at an unprecedented scale and speed. This is most apparent at surveys and excavations that were born digital over the past decade and are thus able to take full advantage of the services offered by a growing number of digital repositories for shared archaeological data. Yet for projects with a much longer history, moving from a traditional system of record keeping to a digital archive is much more complicated. The advantages are clear enough. If they're properly maintained, digital archives serve as an excellent way to provide global access to archaeological records that are themselves becoming artifacts of an earlier era. This is especially the case for the more traditional handwritten field notes. Brad's already talked about this, which are often the only account of an excavation and are therefore not permitted to leave a site's archive. Thus, a collection of electronic resources eases the burden, not only on scholars who must otherwise travel to an excavation to carry out research, but also on the projects themselves, who often face the logistic challenge of accommodating visitors throughout the season. At the same time, though, the push to digitize these older projects' legacy data has brought with it a number of troubling developments. The first has to do with the costs of digitization. Even though most agencies now require a digital data storage and dissemination plan as part of any request for funding, there are very few organizations left that offer financial support for the mundane, time-consuming, and costly process of turning older archaeological evidence into electronic files. As a result, only the most well-funded excavations have been able to engage in the type of large-scale, multi-year program that is required to digitize the tens of thousands of documents and images that make up an archaeological collection. Thus, instead of providing increased access to a wider range of archaeological evidence, the trend toward electronic-based research has had the unfortunate effect of privileging information of the big digs over that of their less digitally visible peers. Yet even when they're able to afford a program of digitization, projects face the difficult question of how best to turn a record-keeping system that functioned quite efficiently on paper into an equally effective system on a computer. For example, at any number of excavations, the field journals are incredibly rich and complex documents that contain a diversity of information types. I mean, they're beautifully messy, you know, if you've had a chance to sort of thumb through them. In the pages of each volume, one can find handwritten notes, edits and revisions, pasted photographs and drawings, and even occasionally the traced outline of a small coin or other artifact. Most importantly, there are frequent references to other field journals, maps and plans, and records of inventoried objects. On the one hand, photographing or scanning this document faithfully reproduces its rich visual content, but a computer cannot easily search the resulting file. On the other hand, a simple transcription does not accurately represent the interrelated nature of the written and visual evidence, nor does it easily enable a reader to differentiate between original entries, later edits, and additions. So this is just a quick example. What I did is took, like a couple days ago, I took a spread from a notebook and tried as best I could in a Word document to sort of faithfully reproduce. And so I've marked, like, you know, this text is red, this is in a different handwriting or something. And I don't think it really faithfully reflects, it does a fairly good job. I don't think it really faithfully reflects the kind of interesting content of a notebook. More significantly, it's important to recognize that in spite of their idiosyncrasies, all archaeological projects have developed systems of documentation that depend on several forms of evidence that must function together to recreate the fullest impression of the past. Within these systems, and depending on the types of questions one is asking, certain forms of information are clearly more important than the others. For example, a photograph of an artifact does not tell us as much as an archaeologist's account of that object's discovery. Thus, the transformation of a collection of physical records into separate electronic files runs the risk of creating a false sense of equivalency among all data. For those familiar with a project's recording system, this does not present an insurmountable problem. One simply gathers the electronic equivalents of the physical records they would normally consult. Yet in the context of a digital repository for shared archaeological data, the important relationships and hierarchies of resource types are masked by the uniform appearance of information as it is typically displayed. This is not to say that records in a digital repository are lacking proper documentation that helps to give them meaning. But in the increasingly open environment of linked and open data, it's more and more likely that a digital archaeologist will use information without first-hand knowledge of the underlying interpretive structure that helps to give it meaning. What is more, in the generally isolated environment of electronic research, there is typically no one present to provide the type of collective institutional knowledge that remains one of the strengths of being physically present at the site. In the field of classical archaeology, where the unique details of each project's system of documentation is as much a point of pride as its artifacts, summary reports and robust metadata schemes may not be the most effective replacement for a conversation with a project director or an on-site specialist. Over the past few decades, archaeologists and archivists at the Ohio State University excavations at Isthmia have had to deal with many of these issues as part of the project's ongoing effort to digitize nearly 50 years' worth of archaeological records. Today, we would like to present the Archaeological Resource Cataloging System, or ARCS, an open-source digital asset management solution developed with funding from Michigan State University College of Arts and Letters and an NEH Digital Humanities Startup Grant. As this presentation will show, we've designed ARCS from the beginning in order to provide a low-cost alternative for projects like ours to manage and disseminate digitized documents in a way that is responsive to their own budgetary constraints and research priorities. From its crowdsourced approach to its intuitive user interface, many of the unique solutions we've developed are the result of a concerted effort to reintroduce the benefits of hands-on research at an actual archive into a project's digital repository. And now here's the part where I had to lean on my programmers, and I've never felt older than when I had to ask my 20-some-year-old programmer to explain to me how he wrote the script. He took on this voice that reminded me a lot of how I talk to my father when I teach him how to use his iPad. So bear with me. Technically speaking, most of the ARCS code base is client-side JavaScript written in Coffee and built on open source libraries like Backbone.js, jQuery, and jQuery UI. The overall look of ARCS was created starting with Twitter Bootstrap and further modified with custom components. ARCS relies on modern browser technology to provide features like multi-file asynchronous file uploads and in-page URL updates. On the server side, a Cake PHP application provides a RESTful JSON-based interface, renders HTML templates not rendered client-side, and handles image and document processing. Data is persisted in MySQL with an optional Apache Solr search integration. The end result, I believe, is a dynamic web application that employs the same types of interactive click and drag icons that are commonly found on most computer desktops. Aside from a faceted search utility that replaces many of the checkboxes and form fields commonly used in complex database interfaces, ARCS encourages users to interact with the information visually, just as one might scan through the pages of a book or a whole pile of photographs. I'd like to demonstrate a few of the more innovative features. First of all, ARCS displays any digital copy of a resource in a manner that replicates its original appearance, but also allows it to be searched and linked to other resource types. This is done in two different ways. For each unique resource, keywords can be entered through a consistently formatted user interface located in the Notations menu to the right-hand side of the page. Any word entered here becomes a search term, as well as a possible link to other resources that have used the same expression. So what we're talking about here is, the resources are displayed here, and then the info tab will provide metadata. The notations tab can be left up, and as people scroll through the document, they can add keywords easily here. You can see I'm in the process of adding the word lamp. We'll get to annotations in just a second. However, because many forms of evidence contain specific references to other types of information, ARCS also allows the creation of what we're calling annotations. When the Annotate button on the toolbar near the top of the screen has been selected, ARCS enters into annotation mode. This now a user simply draws a box around a specific part of the resource that is of interest to them. A menu box immediately pops up, and a user may create a link, or what we're calling a relation, to a resource within ARCS. They can transcribe part of the highlighted text, or they can link to a URL outside the ARCS system. So these are your options. So we're in annotation mode. We've drawn the box, and here we can relate. You can search here for resources to relate. You can click here and transcribe text that's been handwritten in the document, or we can link to things like JSTOR. Once the annotation is saved, a permanent link is formed and can be followed by clicking on the area indicated by the window. All resources in ARCS are identified by a stable URI, so there is no danger of broken or misdirected links. Annotations can be overlapped, and if a user finds them distracting, they can click a button and hide all of them from view. It's important to point out that all annotations are saved and displayed independently of the file that contains the digital resource. Thus, in its ability to augment, but not alter the appearance of the archaeological evidence it displays, ARCS successfully bridges the gap between digital data and an actual material object in an archive. Next, because the process of keywording and annotating tens of thousands of resources is an enormous task, this is already talked about in the last talk, ARCS employs crowdsourcing to augment the data it contains. In essence, any concerned individual who's been deemed trustworthy and given the appropriate digital permissions may annotate or keyword any resource in the ARCS database to which they have been given access. Of course, leaving a task usually entrusted to a small team of dedicated archivists to a much larger and less reliable group of scholars, students, and volunteers may seem like a recipe for disaster. But ARCS is equipped with tools to ensure the reliability and accuracy of user-generated information. First of all, users may flag any resource that appears to contain an error. So what you're looking at is the flag dialog. The button to flag a resource is right up here at the top. So if you notice something is incorrect here, you call up this dialog and you're allowed to enter information. Users then with higher level permissions are alerted and can respond to the issue. Actually, it's not possible for anyone to correct an error in ARCS without first creating a flag that describes the nature of the problem. While this process may seem cumbersome, it's designed in order to generate a history of changes to each resource so that those managing the system can determine what modifications were made and for what reasons and when. All user activity is also logged by the ARCS system so that those with a history of reliable entries or reliable sort of crowdsourcing efforts on the site can be given the ability to edit resources themselves, so people can be promoted to higher levels of access. This crowdsourcing approach also applies to the creation of new resources and their associated metadata. ARCS is equipped with an upload utility that allows users to create resources from single files, or you can drop and drag whole batches of files into the system. Upon uploading, ARCS requests a user to enter metadata for that resource, but only a title and unique identifier, and then the designation of what resource type it is. Those are the only things that are initially required. So what I've done here is I've simply taken a PDF and I've drug it over the top of this box. It's ready for upload. I simply have to enter title identifier and then pull down and say, is it a notebook, is it a photograph, is it a handwritten document, so on and so forth. Right. Once a resource has been created, ARCS relies on a collective effort to augment its metadata. Again, users with appropriate permissions access the metadata menu by selecting a resource or a group of resources, so you can batch update metadata for things of similar type. Let's see, you can select a whole bunch of things and then you click on the edit button near the top of the screen. The menu that appears displays all of the available metadata fields, each one of which is briefly described by an informative help text. So the little eyes here should suggest ontologies, should suggest terminology specific to different digs. At present, we've employed a metadata scheme that's very, very loosely based upon the Dublin Core 15 core element attributes, but we found this to be less than well suited for our purposes. Another reason that this session is so nice is I've now had the chance to meet somebody who's going to help me a lot with this, and well, many people who are going to help me a lot with this, but we've only recently learned of the development of ArchaeoCore and are particularly excited about the possibility of implementing this scheme into the ARCS system. Beyond the creation and augmentation of digitized archaeological resources, ARCS is equipped with a number of tools that allow individual scholars to explore archaeological evidence in a web-based environment that more closely resembles the type of research that they would do if they had traveled to the actual material archive. Understanding that different research questions require different approaches to archaeological information, we've created an opening page that encourages users to explore information thematically. In this way, ARCS replicates the research process in a traditional archive, where one might begin their investigation by consulting the maps or the photographs or final reports for a specific year or location. Because the excavation notebooks form the central unifying element of the ISMEA system of record keeping, they have been listed first. But the order of this opening display obviously can be modified to highlight any form of archaeological information that a project might want to emphasize instead. Once they have identified relevant resources, users can create collections in the same way that they might stack atop their desk the different field journals, photographs, and other documents they wish to consult in an archive. These collections can be saved for later use or shared with collaborators by means of a stable URI. So every time you create a collection, it generates a new URI, so you can say, hey, here's all this data I've collected, let's work on this, here's the link. Each individual resource is also associated with its own discussion tab. Here users can post comments or questions that are permanently associated with that resource. In this way, those who are more familiar with a project and its history can help to generate a permanent form of institutional memory that is one of the benefits of work in person in archaeological projects. So if, for example, the page we're seeing here presents some sort of problem of interpretation, you can post the question on the discussion tab, and then it sits there, and the next person who's going to come to this page, potentially as part of a collective research effort, can say, well, I've got an answer to that, go look at this, or something like that. Although it's still in development, the ARCS system has already demonstrated its utility at ISMEA, a project with a long history of archaeological exploration, but with limited resources that can be dedicated solely to the process of digitization. The crowdsourced approach that lies at the core of the ARCS system allows projects like ours to digitize and upload data whenever it becomes possible to do so. As the amount of information grows, ARCS expands in size and complexity along with it. At ISMEA, where the digitization of records has depended a great deal on the efforts of student volunteers, ARCS has also provided a way to ensure archaeological evidence is being reliably and consistently created without the need for constant supervision. Moreover, ARCS holds a great deal of potential as a tool for collaborative research. In recreating many of the benefits of on-site study, ARCS enables year-round scholarly cooperation regardless of the scholar's location. What is more, by acting as a central repository for a project's archaeological evidence, ARCS ensures that all participants in team research are making use of the same up-to-date information. At the same time, because ARCS can be easily modified to reflect the unique organizational structure of projects that began decades before the digital archaeological revolution, the system allows excavations and surveys to retain a great deal more control over the way that their evidence is interpreted by those who are less familiar with the project as a whole. Finally, the ARCS system is already proving worthwhile as a tool for effective teaching and public outreach. As a recent test of the system in the classroom setting shows, ARCS can be used to educate students about the archaeological process as well. Last spring, we tested over 150 students in an online course taught at Ohio State last spring were given the task of creating archaeological reports based on the primary documentation of a recent excavation made accessible through ARCS. A much smaller group under my direction, students at Michigan State, continue to use the system to update and annotate resources, both in Greece when they're with me on study abroad and then here in the United States. It's important to point out that because ARCS has been designed to allow individual projects to maintain a high level of control over their own digital archive, any excavation or survey that wishes to create an ARCS-based system should realize that with this individual approach comes a great deal of added responsibility. For unlike archaeological data repositories such as ADS and TDAR that offer the benefit of reliable and secure storage, ARCS-based projects are solely responsible for managing their own electronic data. This means that any project using ARCS must first identify a hosting service that can guarantee long-term and reliable storage at a reasonable and predictable cost. Ideally, a project will also choose to create a content backup and delivery system, similar to a LOCKSS network, in order to protect against loss of data. Currently, ISMEA's version of ARCS is stored on servers at the College of Arts and Letters at MSU, with plans for a mirror site at Ohio State University sometime in the future. In addition, each project must also determine for themselves whether they wish to preserve the type of careful control of data that came with managing a physical document archive, or whether they wish to participate in a program of shared and open data. Because ARCS was created for ISMEA alone as a test project, we are now beginning to develop an export utility for ARCS and have yet to institute a clear protocol that would allow data to be shared between different projects. The code for ARCS is freely available, though we hope that other projects will join us in further developing what we feel is a unique and innovative solution to a problem facing many archaeological projects today. Detailed instructions concerning the installation and modification of ARCS can be found on the help pages at the current ARCS site. On a final note, while the source code and revision history of ARCS program is freely available on GitHub, we are also hoping to identify projects that would like to participate in our ongoing effort to explore the ways in which digital archives can improve upon the recording systems of the past. We would welcome the opportunity to speak with interested individuals after this session. As classical archaeologists, our subject material may be centuries old, but this does not mean our methods of study have to be antiquated as well. Thank you.
Okay, we'll take questions. Yes.
So, how have you chosen to handle disaster recovery and backups for your system? If you only have a site and installation on the servers of the university, how are you dealing with backups and redundancy in a single location? What will happen?
Right. So security and longevity of data, I mean, that's really the issue. And this was basically just a proof of concept thing that kind of has already morphed into implementation. And so this is definitely an issue that we have to deal with. And what we're shooting toward is the sort of lost content. Lots of copies of this archive kept at different places in participating institutions. And the idea is that they are all sort of synchronously updated. And therefore, if one server goes down or if there's a horrible accident or something, you have other versions that sit at other institutional databases or other institutional sort of computer systems.
You're not planning to do at any point any sort of like tape archival systems or anything in case one of those copies inserts bad data into the synchronization?
It's something that, it's something that we should take into consideration. Thank you.
So there is Mary and then Jonah behind you.
How long do you think your software will be supported?
Right. So these are issues as well. I mean, we're going to have to deal with once again, this is sort of just proof of concept right now. I mean, but we're going to have to deal with iterations and versions of the software and how we keep the data updated and things like that. These are issues that I'm really anxious to talk to other people about.
So you don't have a current plan?
No, not currently.
This system looks really good for dealing with live data, but have you thought about an export mechanism to take it, like when a project is finally finished with a major phase or completely finished or whatever, of taking that out of here and dropping it into open context or TDAR?
So this is one of the things I'm really hoping to have conversations with the TDAR folks and to talk to Sebastian about this kind of thing. I mean, the idea would be what we're hoping with additional funding. What we're hoping to do is actually create an installation utility, so you don't just have here's all the code on GitHub, go do it yourself. And it would start to add part of the dialogue for the installation would be to ask people about their ontologies, ask them about their metadata. How are they dealing with their categories? How are they dealing with their typologies at their own specific project? And then have a sort of ontological migration tool built into the system, so it can then say, well, this is what you're calling it, but ARCS understands it this way. And then the idea would be to work with folks like TDAR so that once a project gets done digitizing their legacy data, it comes as a package, and then you can move to open context. You can move to TDAR and say, here it all is, all prepped, and it's ready for archiving.
Yeah, something like the ontology mapping tool that TDAR has.
There you go. Right.
Adam.
Can I ask the complement of that question, which is, what about pulling stuff in that already has metadata in a spreadsheet or a database or an XML document so that you don't have to hand enter it again? Because I can see total utility, especially for the annotation tool and the collaborative stuff, but I don't want to have to enter all my metadata by hand.
Right. And this is something else that unfortunately it's just that there's only so much money in the digital startup thing.
But are you scoping that for the next phase?
Yeah. It's sort of is a better import export utility that can actually take that data in and integrate it into the sort of visual display. I mean, one of the major goals of this was just sort of to encourage the idea of the kind of accidental discovery and visual play that often happens in an archive. You fan through index cards or fan through books, and you go, well, this looks like that. And, that kind of thing.
Other questions? All right, thank you, John.